All right, what I need to do is take control back from you. Forgot to do that. Good morning, good afternoon, good evening to people around the world. Oops, just making sure I'm showing the right screen here, and we are. That's the one. Yeah, I can always manage to mess something up, but that's the joy of doing a live broadcast with very little engineering help here other than myself. My name is Martin Hubel, the host of the Db2 Night Show. I'd like to welcome you to our last show of season 13 for Db2 LUW, episode 246. And our special guest again is Michael Roken of the IBM Toronto Lab. How are you today, Mike?
Very good, thank you. Thanks for having me.
Yeah, it's great to have you back. It's always good to have the developers on because it certainly means the information is coming direct from the source, so to speak. But having said that, let's move on and get the housekeeping out of the way. And as always, here's our social media. Replays are now on YouTube. You can follow the Db2 Night Show off the replay blog, or you can find it yourself through our YouTube channel. And as always, the best way to follow up on Db2 Night Show news is through the hashtag Db2Night on Twitter. I make sure to send out notifications when replays are available, as well as when shows are upcoming in the various weeks we have them. Here's our famous disclaimers. Everything's copyrighted. We respect the copyrights of our guests and other organizations. We record things and make them available thereafter, and everything's copyrighted by DBI, all rights reserved. Moving on, we'll do our quick announcements, which are getting rather short at this time because we always, as we run out of shows for the season, we just advise you to watch or suggest you watch the replays over the summer. And we also have next week's show, which is the last show for C, and that's on DB2 version 13. It's all of the high availability, efficiency, and application stability things that us technical DBAs love to talk about, and so you will want to be you want to look at that as well. And as always, the founding sponsor of the Db2 Night Show is DBI Software. They are a Db2 LUW vendor. They also have SQL Server versions of their products coming out of your SQL Server shop, and they have a new DB2 Performance Web Suite available, version 7. And so you can see that off their site. It's pretty easy to find if you go into the products page off DBI Software. Our winner from the last show was Michael Braun of FleetCore. He won himself an Amazon gift certificate. Thanks for watching, Michael. And good luck to everyone else that's watching today. And we have co-hosts and training. I mentioned these guys last week. They were around here a minute ago. And with any luck, I might have a special thing for you. Where are you guys? Where are you? Lily, come here. Okay. It's okay. It's okay. All right. I managed to corral the guest star. Things that you do when you're at home and you have to amuse yourself. What I'm going to do is turn on my webcam, and hopefully this will be working, and it's starting to work now. One thing about Chihuahuas I found out is they like to sing. You want to sing? Not doing it on demand.
Camera shy.
There we go. There we go. You got the whole effect. So that's what one does. And yes, I'm wearing the old responsive system shirt, which is nice and bright and colorful. But we won't subject you to any more of that. But it's when we get the extended Chihuahuas in our family now, we now have 4 Chihuahuas that will howl in the backyard. and it's super cute. But Lily is the most willing participant of all. So the old saying goes, you heard it here first. Thanks to our sponsors, again, DBI and yours truly, Martin Hubel Consulting. And with that, we'll move on to our polling session. And then here whoops, daisy, it was there a minute ago. We'll launch the first poll, which is our standard question, which is what DB2 LEW versions are you currently running? And today I'm giving everyone a chance to do all of them, or as many as you currently have going. And people are voting away there. We're getting that out of the way. And with that, I'll close that first one off and share the results. And you notice that we have all sorts of people on at least version 11, if not 11.5 and higher. That's great news. We'll close that off. The next question is, what platforms do you run DB2 on? Again, this is a multiple response poll. Again, this should not be a surprise. Some of the new functionality, including containers, is available on Linux only, so more and more people are moving towards that platform. And again, we'll close that off and share that result. Linux is now in the lead. For years, AIX was the leader of the leading platform, but still people have a lot of it around. Next question, what other commercial DBMSs do you have? This is the standard 5 right now, I guess you'd say. If I've forgotten any, people often remind me of that. It's an interesting result today. People that run DB2 LEW, many of them got here because they run DB2 on Z as well. Thing I'm finding a little surprising today is that SQL Server is way ahead of Oracle today. That's rather interesting to see, and there's a lot of Teradata out there in our good-looking audience today. But open source products, I updated this list, and clearly I forgot to make it multiple. Oops. I can always manage to mess up one of these polls. See what people are running, or your most favorite, or what you think is the most strategic to you. I apologize for not remembering to make that a multiple response question. And we're getting some interesting responses there. I put in the last two, and the reason I did that is some of the developers in Toronto moved off to work on things like Cockroach and Snowflake, and I just interested to see how many people in our audience would be looking at those products. And right now the answer is 0. Mongo, MySQL, and Postgres are all equally represented. That would be different, of course, if yours truly had remembered to make that a multiple answer thing. And something specific to the question or the topic today is, are you getting the transaction log full problem today? Meaning, have you had that problem? And just interested to see how people respond to this. This is something that the IBM wanted to address, and so we wanted to see how people felt about that. And you either know it or you don't work in that area, but it's good to see how people feel about that. And we've got about the same number of percentage of people that have voted so far. And out of our audience, 45% have said yes. It's interesting to see. 36 no, and 18% don't know. So that's kind of interesting to know. Okay, and that I believe is the last question we're going to ask you right now. So we'll move on, and I will turn things over to you, Michael. Just find you here. Should be seeing a note on your screen right now that gives you a chance to show your screen.
There you go. Can you see it?
I can. You look It looks wonderful. Nice and nice IBM blue there.
All right, cool. Thank you very much.
Michael, as always, I'll be watching the question queue, and I will burst in with any questions at an appropriate time where I can ask those to you to make the session a little interactive. I'll also mute myself for the time being, so you don't hear any cross talk or any leftover howls.
Okay. the dogs, yeah, it's funny. That was a cute one. Yeah, okay, yeah, no problem. I guess at any time you can jump in and say if there's a question on the queue there. Otherwise, I will stop from time to time and just kind of pull back to see if there's any questions. So we can do both at the same time. So that sounds good.
Great.
All right, you can hear me all right? Loud enough?
You sound marvelous. It sounds like you're in the living room.
All right. Yeah. All right, cool. All right, again, thank you, Martin, for having me on the show. I appreciate it. And thanks everyone for joining today. Friday, we're getting into the summer, so anytime people can join, I appreciate it. I love getting people's ears to talk about this. For some of you that may know me, or those that don't know me, my name is Michael Roken. I'm from the IBM Toronto lab in Toronto. I've been a developer there since 2000. I started in backup and restore, then sort of moved my way over to more general availability things, like especially with the PureScale project. So I've worked more on transaction management, log file management, HADR. So pretty much the whole sort of availability realm is sort of things that I've touched now here and there. The big sort of thing that has kept myself and our area busy the last few years is this feature that we're going to be talking about today, Db2 Advanced Log Space Management, or ALSM. It's a project that we came about with in around 11.5. It came out in GA 11.5. I have a timeline later, but I like to kind of set the tone. So suddenly came out with a tech preview, and then over the doing iterative design, the new way of doing things, over our mod packs as we released, we've incrementally improved upon it. And so, we're now at the stage with 11.5.6, which I believe we shipped last year, early summer. Now we have full support for production systems. Yeah, we're here trying to get the word out to make people aware. Really, the whole motivation was, transaction log full. That's why we had the question. So to see 46%, I think it was, people being impacted on the call today, that's good news, because it's good to kind of, the people who are going to hear this message, you can already relate whether it's going to be, useful for you. Is it going to impact you? Is it going to actually, something that you can explore? I guess maybe I should have also asked how many are maybe already using it, but in any case, that's not a big deal. So let's jump in. Just a little disclaimer here. There will be something at the end that I'll talk about the future. So I like to always put this disclaimer that anything future statements-wise may be changed. So that's just that typical stuff. And like I said, today we'll talk about advanced log space management. I had a deck from previous years that was sort of pretty big, and it was tough to get it through in 1 hour. So I've kind of gone through that, condensed it a little bit, tried to pick out the really highlighted pieces. I had a lot of sort of information, like introductory logging sort of stuff. I'm going to assume, and it looks like from this audience, that there's a bit of already logging experience. So I'm going to jump right into the problem and the overview of what the solution does, and restrictions, limitations. So that's what we're going to be talking about for the bulk of the presentation. At the end, there's a little bit of monitoring. Obviously, with any new feature, monitoring is key for customers to see whether the feature is working the way they like it. So we'll talk a little bit about that. I'll just introduce you to some of the monitoring features that are there. And then, like I said, there is where is ALSM going in the future? Right now the feature is pretty big. You'll see as we talk about that. So we couldn't capture everything at once. So we have to kind of pick out those case statements that most of our customer base, that would satisfy the bulk of our customer base. But definitely there's still room to go, things to improve, and feedback is always key. So that's definitely something that we're looking at from our customers as they start using this feature. So what is transaction log full? I guess that's the good question. That's why we're all here today talking about advanced log space management. So pretty much transaction log full, for those, a little refresher, we have a transaction log space configuration. If you go through our database configuration files, our database configuration, and you do all the listing of all the parameters, you'll see there's a lot. And from that list, I used to have the screen over almost about half, just, I'm not kidding you, almost about half have to do with log space management, okay? So logging itself is a very key integral part of the health of the database because it's performance driven, right? If you don't have the right tuning system, then you're not getting the most out of it, and you're getting bottlenecked somewhere. So, transaction, management, log file management is pretty key. So what we have here, we'll only talk about a couple of these parameters, is, when we start up, we have a fixed log space. So when we activate a database, there's a fixed log space. That fixed log space is based on your log primary times your log file size, okay? That's how much space we'll carve up, and that's how much space we expect our users to be there for the longevity of activation. Usually that's done based on people forecasting what workloads will look like. There is no magic formula. Unfortunately, I wish there was. I get that asked frequently. But really, it comes down to, it all depends. The typical question that everyone gets asked, it depends. And everyone gets annoyed when they get answered that way. But it does depend on your workloads. It does depend on, your disk systems, how fast, and those types of things. So what we do is we come up, we have our fixed space. If by any chance that, magic formula doesn't work out and you have like peaks of workload and, files greater than your log primary are necessary, that's when we have something called log secondary, okay? And our log secondary are what we call on-demand allocated files. So like I said, you'll have your log primary. If all of a sudden let's say that's 10 just for the hell of it. If you need now a little bit more, as the workload realizes that the current 10 on disk isn't big enough, it'll start on demand allocating one extra file, then another extra file, then another, and then another, as much as it can satisfy the requests. So every time there's a on-demand request, there can be noticeable blips, if you want to call it that. Some customers don't, ideally that's minimal, and in most cases it is. But in some situations, there can be, if someone was really graphing that along of how, workload thresholds were happening, every time there was a log second, you probably will see a little minor blip in the line. And that's due to, latching underneath the covers to go out and allocate new files for this log secondary. So ideally, you get two camps of people in terms of when they come up with these configuration parameters. Do we come up with a big log primary and no log secondary? Do we come up with a medium log primary with a big log secondary? Those are the types of calculations that customers usually have to do. And let's be honest, they're not easy, okay? And so with ALSM, this is the type of thing that we're kind of, starting upon. It's not perfect. Like it's, there's still room for improvements and things that we want to do that we haven't accomplished. But, we've kind of taken the guesswork a little bit out of coming up with the right configuration, and we kind of manage it under the system, which you'll see in a few moments. Okay, so coming back to the, what is our active log space? So that's, as I described it, as you see here on the screen. So two other parameters that are interesting when we're defining this is what we call low tran and min buff. So low tran is what we call the first, low tran pretty much is the log record that belongs to the oldest open transaction, okay? So by doing that, that's usually needed for, crash recovery purposes, okay? So if obviously we want to have a crash consistency, if your database is doing workload and, we keep always the files from low tran local on disk so that if you happen to crash, we quickly get to, that oldest transaction, we start replaying everything. That's how crash recovery works. Minbuff is equivalent in that that's all about dirty pages. So it's about buffer pool flushing. So usually we will start recovery from the minimum of those two values, okay? So, and that's the way that's how we do things, right? So if low tran is the oldest, then we need to kind of replay those log records between low tran and minbuff. So we have, we can build our transaction table. And then if minbuff is older, then we want to replay those log records because we don't know if they made it to disk. And so we need to replay those log records. So that's sort of the, the important factors of low tran and minbuff. Okay, and as I mentioned, ideally for quick crash recovery, we want to keep all log files on disk based on the minimum of low tran and minbuff. And that log file, that earliest log file that we keep on disk is what we call head extent or head log file. We call it log files extent, so you might see me say that from time to time just because I'm so used to it. But when I say extent, it means a log file, okay? The same thing goes for rollback. So at the end of the day, if you need to read your logs for, like I said, either rollback or crash recovery, you want to keep the files local. The more the data is local, the better, because it's the quickest that you can possibly get in terms of reading. Okay. So when transaction log full occurs, that's pretty much a situation where we've exhausted all the fixed log space, including the on-demand. So, log primary is the fixed, log secondary is the on-demand. When we've exhausted all of that, that's pretty much when we start throwing up our hands and saying, hey, the transaction log is full. It's not a physical problem, although it could be if you happen to allocate exactly the physical space, but it's more of a logical problem. Ideally, when you configure your database systems, it's nice to have all your logging paths on independent file systems. Okay. Obviously, the more things that write to the same file system, the more sharing of the work that's being done. So if you have, like, say, an active log path and you have your own file system for it, you pretty much know that you're the sole user. DB2 is the sole user of that file system for logging, and that can help with performance. Same goes if you have a mirror. Same goes if you have an overflow. Again, that's a lot of stuff to manage, but that's the performance sort of aspect of things. If you want the best of the best, then you got to put a little bit of manual effort into configuring those things. So in any case, if you get a transaction log full problem, that's actually what we call a logical problem. Okay, it just means that your configuration wasn't big enough to manage the workload that you have on the system. So that meant you did your math wrong. Okay. So this is where people, usually will, like I said, set a certain log primary that seems adequate, and then they'll have the log secondary for on demand. If you have, in the end of the day, log primary plus log secondary times log file size will be the maximum amount of log space that we would use. So it's kind of debatable. Like, might as well, if you're going to use that space at some point, or you want that space to be used at some point, then you might as well configure your system fully as a log primary to just say, hey, up front, I'm just going to take this all. That's what my size is, and DB2 go work with this, right? Rather than doing the on-demand. So again, like I said, there's two camps that people are from, but in any way. So the diagram that you see here down below pretty much is just an example. Here's the disk system carved up. I did a very contrived, simple example. Log primary is 8, log second is 0. You can see low trend is the one that's holding up head extent, and minbuff is sitting here in log 4. And so what happens is every time we're doing logging, part of the transaction model is you need to reserve your undo space up front, okay? So for rollback purposes, for example, right? So every time you're inserting data, you can kind of figure that you need, I don't want to say exactly duplicate, but think about for everything that you write to redo, you have similar space requirements for the undo, give or take, all right? So pretty much you start writing into 4, which means these last 3 files have already now been reserved for compensation log records in this case of a rollback or a crash recovery, for example. So what that means is I have no more room to write into log file 7, which means I now have to write into log file 8. But as you can see, 8 is now the 9th file, sorry for that, is the 9th file, and that exceeds what we had allocated for our log primary and our log second. And so as soon as that happens, you're going to see your transaction log full problem. Okay, so that's what that is. Like I said, 46% of you reported this. So you guys are aware of that. You have seen that happen before. For those of you who have not hit it before, that's great. Good, very good that you're not hitting it. Maybe you've done your math right. But it's still good to have this in the back pocket, because as time goes by, systems change, workload changes. And one thing that, ideally you don't want to have to do is constantly have to go back and revisit your configuration parameters. Okay. So that's why with ALSM, what we're trying to do is we're trying to move from, beforehand manually configuration to eventually one day more autonomic logging. Okay. So we're not there yet. We're probably far from it, but we're starting right now. Okay. So before I go into the next slide, I didn't put this in here, but I'll mention it real quickly. This is transaction log full. So some of you may already, you already experienced this. You realize that, hey, this happened to you, and DB2 already offered up a solution. Okay, DB2 does offer something called infinite logging. Okay, infinite logging is set up when you set your log secondary to -1. And all what infinite logging does is it pretty much allows these earlier files. So based on the example that I have here, if I needed to start writing into this log 8, I would be allowed to do so because we would allow head extent to move over 1. So just consider it a shift, okay? There is some logic in place. So, as soon as this number 0 file is allowed to leave, it now goes into what we call cached files, okay? And as a cached file, there's a bit of management. We only keep a certain number of cached files. So over time, I think it's like 8 by default. So we keep 8 cached files. So at some point, if Lotran is not updating itself, so you have a really long running transaction, eventually you will get a situation where here you see the log files go continuously from 0 all the way 7. But at some point, if you're growing 8, 9, 10, 11, 12, all the way up, you will start to see gaps. You will start maybe at some point, after log file 7, you won't see 8. You'll see no 9, no 10, but you will see maybe a 20, 21, 22. There will be holes, okay? And that's because of infinite logging. Infinite logging overcomes the log file configuration by allowing the physical log file to be archived and then that space being reused locally, okay? As soon as that happens, that's great for avoiding transaction log full. You won't get it anymore. But the problem is when you have to start doing rollback or crash recovery. In those situations, if any of those operations need to happen, the log file to read the data potentially is in one of those files that's no longer local. And because it's now up in the archives, you need to do a retrieve, okay? And that's where the performance problems come in. And that's the Achilles heel, so to speak, of infinite logging. It achieves the solution of avoiding transaction log full, but it comes at a cost of performance for crash recovery and rollback, okay? So that's where the picture stands of what DB2 looked like pre 11.5. Martin, I'll stop there for a second. Are there any questions? I've lost Martin. Okay, no problem. I'll carry on. If there is any questions, Martin, just jump in and stop me. Okay, so now we start talking about 11.5 and we start talking about log space management and what is it, okay? So I have a few slides that goes through the entire solution. Pretty much what we have here is a picture. You can see up top here we have the active files, S through to S4. And what we have here is these are log records. These little boxes are log records. The committed log records are blue and the uncommitted are, I don't know, this orange fuchsia color. So what we have here is as soon as we start writing all this log data, we have now a system that runs underneath the covers, checking whether, is log space management, are we eventually going to hit transaction log full? Are we pushing the limits of our currently active log space and the requirements that the user has, okay? As soon as we start realizing that there's a potential for a transaction log full problem, we have this thread that we call the log extraction. We call these EDUs, but a log extraction thread or process kicks in and starts sort of scraping the log files, looking for data that's uncommitted belonging to long-running transactions, okay? And so what we do in those situations is we take the data, the uncommitted data from those log files, we copy it. We use the word extraction, but it's literally a copy. We copy the data out of those active files or our S files. Those are our active files. And we copy them into secondary files with the X files, so to speak. And we call those extraction files, which I'll talk about in the next slide. But pretty much that's the process. It's not earth-shattering what we do, but the mechanics to do it properly, efficiently, timely, like those are all the things that really, there's a lot of throttling and a lot of management under the system to make sure that's done with as little impact to user workloads as possible. I'll touch upon that in a second. So based on this diagram, what you see is all the orange, let's call it orange, all the orange log records, we now realize that there is a potential for transaction log full upcoming. And what we'll do is we'll go through and take out those log records and put them into secondary files called extraction log files. Okay, once we finish extracting a log file, so let's say we did S0, there's some data here. S1, we have some data here. We're in S2, but we see that there's no actual data. So we just create this meta file for recovery purposes, but we don't actually extract any log data out of it. But as soon as we're done extracting from those log files, the physical S file or active file itself can now be closed, it can be archived, and it can be reused by the system for new log data, okay? In doing that, as long as we do that in a timely fashion, that avoids the transaction log full problem. So if you look at what I just said and compare that to what I mentioned a few minutes ago about infinite logging, you see there are similarities, but you notice the one big difference is the data that you need will always be found local in these extraction log files, which means if you need to do a crash recovery or a rollback, those files are there. You don't have to go off. You don't have to retrieve. Even better, the data is sort of aligned, like each file here is based on a transaction ID. The reads can read in all the data for that single transaction, and that also can help with rollback performance because we can do more optimized reads. So that's sort of the picture of what extraction does. Like I said, it's one slide that captures the entire sort of process, but underneath the covers, as we'll talk about the couple of what's it ideal for, you'll see some of the more complications or the nuts and bolts of it all. Okay. So like I said, what you'll see here are these extraction log files. So there's a very common one. We'll start, I should have done it the other way around, but we'll start at the bottom, the meta file. Okay, the meta file is really, every log file, every active log file. So again, every S file is called the active log file. Every log file has what we call an extent header or a log file header. Okay, that information is critical for a lot of recovery and file data searches and finding things in log files and whatnot. So the meta file mainly contains that log file header, as well as some other stats about what transaction IDs have actually been extracted from. So that meta file will always be there. While an active file is being extracted from, you'll see a temp file or a TMP file. Okay, that's just a temporary meta file in the process of being extracted. Okay, as soon as we finish the file, the TMP will turn into a meta. And then that file is done with, and that file is eligible for archiving and disappearing from the system and being reused. Okay. As we go through each of the transactions, there are separate files created. As you can see here in the example, we have a X00, TID1, TID2. Pretty much those just represent the transaction IDs. So every transaction has an ID. And we just extract the data for those open transactions, and we put them into those special transaction extraction TID. We call them TID files, so transaction ID or TID files. Okay, pretty much these are used for, like I said, rollback, currently committed, recovery, and yeah, that's really what the picture looks like. So when people are running, when ALSM is turned on, and I'll get to that in a second, you will see this new landscape in your active directory. Okay. So the one thing with the extraction files, and this is where, we'll talk about this in a bit as well with restrictions, is these extraction files do take up a little bit of extra space on top of your configuration. So because you have the ability now to extract only what you need, there is a possibility for users to look at their log primary, log second configuration and potentially reduce it a little bit, because now the extraction log files are able to take up some of the space that the active files needed to take up because there was no extraction. Okay, so it's sort of like, of a given file, and we'll talk about this as well. For a given file, let's say 5% of the data. Let's say you have bigger files, and only 5% of the data needs to be kept. Well, that's 95% potential savings if you want to reduce some of your active log space to accommodate for that. Okay, I'll touch upon that in a bit. So that's sort of the overall high-level picture. Honestly, like I said, it's very simple. 2 slides sort of cover the picture. Now the rest of the slides talk about the under the covers. One of the first things I like to show is the timeline, because of the way the iterative nature of this feature is. I like to make sure everybody's aware what's available when, because that dictates where people go and what upgrade schedules. All right. So the thing that you see here is 11.5 GA was the technical preview. Okay, we got it out there for, you can call it almost beta use if you want. People could play with it, but it's not for production use. It was test environments only. It had very limited support. It pretty much just worked for the simple of simple. Okay, then in mod 4, 11.5.4, we came up with production support. So production support still had the limitations. There was no mirror logging, no HADR, no online backup, and no pure scale. Okay, so it was, again, the basic of basic, but we were able to allow, production users for, smaller, simpler shops, if you want to call it that don't have a lot of features going on in the system, to start using it. Then over the following mod packs afterwards, we iteratively added more and more support. So in mod 5, we added basic mirror log support, which I'll touch upon. And then really the big release was the one last year, which was the Mod 6, which was really the biggest heavy hitters for most customers. Was they wanted HADR support and they wanted online backup support of these new extraction log files. So this is where we sit now. Mod 7's came out the door, I think, end of the year. Mod 8 is coming out in a little while. But this is really, things haven't changed since Mod 6. ALSM looks the way it does, so from M6 onwards. So I would say if people are still on the fence, move to Mod 6. That's where you get the best of the best of ALSM. Okay, you'll get everything there. And then we'll talk about what the future holds again in a few slides. Martin, I'll check back again. Any questions on the line?
None from our audience, but I'm intrigued by this because I have a customer that I work with. We've been working with them for, I want to say, at least 10 years. And they have certain functions that they do at times of years where they do a mass insert or a mass delete. So we have been cautiously turning on log second to -1 so they can have the log space to perform these. As a DBA, we would call them an aberration.
Yep.
And then we turn it back off. And I'm looking at this meta files and things like this and extraction files as being something that would be highly useful for those situations, and possibly have us avoid altogether the idea of having to turn on or change to log second -1. Would you agree?
Yeah, exactly. So that is a use case for these situations. If all things, so let's say that, like you said, they have, I call it peak periods, but like your aberrations, I think you used the word. So under normal circumstances, if they never really push the limits of transaction log full, things work as usual. There's little impact, and I'll touch upon, there's little impact to the system. You may not even see many extraction log files, if any at all, okay? It's only when you start hitting these thresholds of when potentially you'll hit transaction log full that the extraction will happen. So if the aberration is, let's say for just let's say 2 days, let's say, 2 days you'll see these extraction log files, you're covered for rollbacks, crash recovery, and then eventually the system goes back to normal, and eventually these extraction log files will disappear again, and everything will go back to normal because there is no requirement to pull data from the active files because there is no stress on the active log space. So that is an example. It actually segues nicely into what I talk about, which is the models for ALSM. The main model for ALSM. Sorry, before I go, Martin, was there another question you had on top of that, or was that it?
That's exactly what I needed to hear. I'm as I say, you can call it an aberration. We can call it one of these 2 or 3 times a year where they're cleaning up membership databases and stuff like that for
yeah. Okay, so that's good. So that leads nicely then into the rest. So I'll touch upon that in a second. I'll just go through the slide here, and I'll touch upon the workload, what it's geared for best. Okay, so first of all, to get this feature, right now it's not on by default. Okay, that's something that we're talking within the lab right now. You'll see as I go through here, turning it on by default can have impacts to people's systems because there may be some shocks to people's system because depending on how you're configured. So if you're a shop that, some customers have, like for my log space, I have literally, I'm using numbers, 2 terabytes. And I use, my log configuration, log primary, log secondary, log file size is exactly 2 terabytes, okay? As soon as you start doing that, that can have some sort of pushback to extraction because extraction never wants to take away from that, at least right now. So what would happen is you would never actually get extraction functioning because we would never want to cheat and steal space from what the user had previously configured. So in a way, it's always add-on space. So in a way, if a customer has, X amount of space for a system, you probably want to use up, 90% of that for your active log space, and the remaining 10% can be for overflow. I shouldn't use that word because that means something, but it's used for extras that DB2 manages on top of potentially what's wrong. So long term, we don't want to do this. You'll see what I'm talking about later. But for the time being, that is one of the things. So if anyone is exactly configured, physically and logically exactly configured, they'll have to revisit that a little bit because ALSM may not function as you might expect because of the way we use up space. We don't want to hinder existing space. Okay. But secondly, you got to turn it on. Okay. So turning it on, there's a registry variable, you turn it on. You do have to balance the database, so a deactivate and a reactivation. So once you turn this on, technically it's on, But the system, there's a lot of smarts built underneath the covers, and that's why, you know, we threw the word advanced on it. We realize and keep track of whether we're providing benefit to the system, okay? So for example, you know, circular logging, we're not really providing benefits because there is a potential, you know, because there's no archiving, because of the circular nature, we're just duplicating disk space. So there's actual physical problem with doing that. Like you're just using up more disk space. Sure, you can say, hey, I can still avoid tran full, but now you have to worry about physical problems. And so that was just not something we wanted to take on. Retain is similar. You know, retain, you're keeping all your files there forever. So now just having X files, again, you can avoid the tran full, but you'll have extra physical requirements because you'll have X files plus your existing S files. That's not ideal either. So again, that wasn't a use case that we looked after because that's not, you know, the most beneficial. The most beneficial were customers who are configured for archive logging, okay? And so that's why this is mentioned a key. If you're configured for archive logging, you turn on the registry variable, ALSM is functioning, ALSM is sniffing, ALSM is looking around, it's trying to figure out how it can help you avoid transaction log full, okay? And it does this by having a new EDU or thread, like I mentioned before. You'll see it if you do a Db2 PD EDUs. It's called Db2 Log X, kind of like some of our other thread names. And all it does under the covers is it actually runs an internal Db2 read log API. Okay, so some of you who might be replication shops, you use the replication QRep, for example, or CDC. They use the Db2 read log API to read log records. So that's a constant log reader on the system. We are doing the same thing. So underneath the covers, not always, but they're always kind of reading something. Is there something to do? Is there something to do? Then we read. And then we use this infrastructure, this read log API, to read the log records, to extract, then pick and choose what we want to extract. So even though this runs, our performance testing, of course, we thought about another, this type of activity on the workloads, it has shown almost none to minimal impact on active workloads. So we do this in a very, the most least intrusive way possible. Yes, there might be a percentage difference in workloads, but that is going to be kept to a minimum. All right. So that's something, if people start turning on ALSM, we have some knobs, you can start doing some monitoring of systems, and you can start seeing if that, a statement that we make is not true, then obviously that's a bug. That's something you would report to us, and we need to figure that out. But internal testing has shown that active workloads are not impacted by this, internal read log API being done behind the scenes. Okay. So the extraction, like I said, is based on policies. Throttling, we call it throttling. So it's kind of throttled on, different policies like, is there disk space? Like I was saying before, is there enough physical disk space to extract data? If you've already maxed out, especially in infinite logging where there is no compensation reservation system, you've already maxed out your whole space and it's physically the same as your logical space, then I can't extract. I can't put things anywhere. So, if that doesn't happen, if I can't extract, then you can fall back and the extraction EDU will go idle. And then what will happen is you'll just, your business as usual, which is you can eventually hit transaction log full. So the point is extraction itself is a best effort process. It goes out. There's a policy that says, it's internal, it's knobs. We're going to work on that as well. But, if 80% of your log space has been utilized, let's start doing some extraction. That's sort of the high level number that we use. Okay. And so disk available, physical is 1. The space consumed, that's exactly what I was talking about. If you've consumed a lot of your space and your percentage is high of consumption, then extraction will kick in. Producing a benefit is the utmost of what we're trying to do. If we're not helping you, then there's no point having us. And if there's no point having us and extraction is not running, that means extraction will go idle. And then if extraction goes idle, then eventually over time, we can't extract the data, we can't move the log files, we can't reuse the active log files, and you can hit transaction log full. Okay. One of the big things, and so coming back to your point now, Martin, with your customer, is one of the things we cannot do well with is monster transactions. Okay. So a monster transaction is a long-running transaction with high volume. If that's the case, then that technically means I'm extracting everything. And like I said before, if I'm extracting everything that's in the active files, then there's no benefit. I'm just duplicating the physical amount of storage. So the best models are 1 or 2 or 3 long-running transactions that log very little. Loads, maybe some indexes here and there. They have these high startup costs where the load transaction may log a couple of things and then sits there for a while then you have your OLTP workload doing quick insert, update, deletes, wanting more log space, but this one old transaction is holding everything up, and then eventually you get tran full. That is a perfect example where we would then kick in and say, okay, that old transaction, let's extract some of the data, move the files up, and you avoid the transaction log full problem. Okay, so that is the best model. There are other models that we can go after, and with time we will figure how to behave best in all workloads. Overall, we do work well. We just, like I said, we turn off if we don't feel like we're providing benefit. So could we do better in those situations? Those are things that we'll learn, and we can find ways to always be better. Okay, so a couple of things why the extraction scan can go idle. Pretty much, we have to archive. We have to extract files before we can archive them. So if you have a bad log archive, if the archive's not healthy, that's a problem. If I can't move the file to the archives, I can't extract from it. So you got to make sure that you're healthy there. Okay, so if you're using TSM or some vendor and there's slow network latency and that's holding things up, that's going to cause a pushback on the files that we have to keep local. And again, if I extract, I'm just duplicating data, which gets me into physical problems, so there's no point extracting. So making sure your log archive is healthy, making sure you have a failarc path set, that's always helpful as well, because failarc path allows us to archive out of the active directory, and hopefully your failarc is in another file system, so there's no physical sharing. So that's one thing to look at. Buffer pool flushing. Pretty much minbuff, what I talked about before, every log record that is after minbuff has to be replayed. So that means I need to have all data from minbuff onwards local on disk, which again means extraction provides no benefit, okay? If it's low tran that's holding you up, then I can pick and choose. And so that's when extraction works best. That's why long running transactions is best model for this. If it's minbuff, then you have a buffer pool problem. That means you're not configured properly for your workload, you're not flushing properly, you may need to update these configuration parameters, so the page ages, the old softmax. You have to start looking at those to make sure that your system needs better flushing, quicker flushing. Instead of having the default 4 minutes, maybe you need to do it every minute, something like that. That's something to look at. Consumption, like I said, 80%. If we notice that you're using up 80% of your space, we'll start consuming. Pretty much, we just want to avoid taking up resources, so we really leave it until the latest possible moment to do the extraction, so that we have as little impact to the system as possible. Okay, we have a high extraction ratio rule, or what we call the monster rule. So this is like one long-running transaction that's literally consuming 95% of the log space. It's the only thing on the system. Even if you have 5 of them and they're the only 5 transactions that are logging on the system, that means and they're running for a long time, it means I'm going to have to extract from them. So you have a monster, ALSM is not going to work well for you, and then we'll have to look at other ideas. So for example, if you're in the warehouse side, there's reduced logging. It's not about extraction going to solve your problem, it's about logging volume, and there we have reduced logging as an example to go after that. And then we have the typical error situations. Extraction is slow, maybe it's just something is going on where we can't keep up. There's just so much workload that extraction just can't keep up. It's rare, but it can happen. And then obviously write errors. We had a problem writing to the extraction files. Maybe you got a physical disk full problem, for example. Then we go into a write error state. That means, okay, I got to stop extracting because I can't give you consistency because I can't get through this log record because I can't extract it. Okay. So that's the overall process on extraction. Really, that thread is there, doing that constantly behind the scenes. So really, that covers that. So Martin, are there any questions on any of those points? All right. If not, stop me. So now that we have gone through the extraction, so now picture yourself, your system's running. You do have some long-running transactions, but we have extracted some data, not a lot, but enough. 3% of your data is extracted, give or take, maybe 10, 20, give or take. You have X files on disk. What are they used for? Okay, so what happens is now if you do a rollback, currently committed, they're all the same in those two, rollback and currently committed. Pretty much what we do is when this happens, the logic says, I need to read this log record to be able to produce the compensation log record. To read the original log record, where is it based in the files? Is it in the active range? Is it in the extraction range? If it's in the active range, okay, business as usual. If it's in the extraction range, then we're going to use the new logic that goes and reads from the extraction log files and supplies you the log record. Because rollback and current, rollback specifically is based on transaction ID, all the data for that transaction is contained in this one file per active log file. So 0, 1, 2, you'll have all your 0 data in, xtid1, all your 1 data in xtid, tid1. So I can read everything from that, extraction TID file for recovery purposes. So I can read a lot more in one file swoop, so to speak. So that has shown performance improvements on rollback of a single transaction because I can read so much and process it quicker. So that's good. So the biggest thing people will ask me is, okay, we have active files. We have data now in extraction files. What happens if there's a corruption with the extraction file? Well, that's the worst case scenario. Obviously, that's not the norm. If you have a corruption in an active file, you're kind of SOL. If you have a corruption in an extraction file, again, extraction files help you, but if the X file is bad, we will go to the archives. Okay. The archives will be our backup of these files. Obviously, at the end of the day, if I can't read a log record from the extraction files, I go to the archives, I will retrieve it, I will use that file. That should happen so infrequently because the X files should be solid, but there are possibilities for things to go wrong. That's why we have recovery and availability. But that's the backup strategy, the backup plan, if you want to call it, which is if the X files are bad, we go to the archives, retrieve, and use that file. Okay. For currently committed, it's a little bit different because currently committed, it's about lock wait. So in that situation, we've kind of assumed that waiting for the lock would happen quicker than going to the archives for the retrieve. Again, you might find that's different. If so, then you can let us know. We can find ways to make that better. But right now, so if rollback fails, we go to the archives because you need to roll back your data. But for currently committed, we're going to resort to the lock wait behavior if there happens to be problems with the X files. Okay. Because the data is extracted, it's a subset of the data. There are certain log reader operations that need to read every single log record from a starting point A to an ending point. So because of that, the extraction files are actually no good for that because X files, like I said, are the subset of the data. So operations like replication, online index recreate or OLIC, table space roll forward, those operations need to read every single file. So if those types of things need to happen and extraction files exist, then unfortunately those will require going to the archives and bringing down the real file, the original active file, and using that to supply the data to the log reading application. Okay. The extraction files are solely for recovery purposes, and we'll see how they work for HDR and backup and roll forward and crash recovery as well. So that's one thing to understand. Ideally, we can improve on that and understand, the only time it's really bad for replication is if you're replicating older data. If you're always, most times replication is pretty close to current write position, then this would never be a problem. And same goes with OLIC. If things are normally up to speed, these types of retrieves aren't necessary, but it is a gotcha or a heads up that this can happen if you're reading more historical data. Crash recovery, database roll forward, they use extraction log files. We start up, we know where the minimum of low tran min buff is, which is our starting point for recovery. If there's extraction files that cover that range, we use the extraction files and we're able to pick and choose that data as it's a subset to recover it. And then as soon as we finish our extraction files and now the rest of the log data is covered by the active files, we transition to the active files and then just do typical recovery there. So you're covered for crash recovery, you're covered for database roll forward. Same thing, if there's errors, we go to the archives, retrieve the file. And the same thing, it works for in-doubt transactions. As soon as for crash recovery, we've extracted, 5 files, maybe there's more to extract. As soon as we transition from recovery to runtime, we just pick up extracting where we left off. It's seamless to the user behind the scenes. Literally, the user should not ever care about extraction log files. They're behind the scenes. They do the job of making sure the data you need is local for recovery purposes. Okay. Support for set write suspend, same, it's just like our log W, our log writing EDU. If you suspend the database, because we're writing to the active log directories, we suspend extraction, integrated snapshot, it all works the same way. There's literally nothing special there. The include logs, exclude logs option, INIDB, snapping it back INIDB, all of that works the same. There's literally nothing the user needs to be concerned about there. Okay, encryption, it's encryption aware. no problems. Your database is encrypted, especially in the cloud. It covers it. The files, the extraction log files will be encrypted also, okay? So the way the active files look, the characteristics, that's the same way that the extraction log files will look. Same encryption key, master key label, all that stuff, all the same, okay? Monitoring, well, we've updated a couple of these monitors. Mon get transaction log is the biggest one. You'll see that in a few slides. There's like, I don't know, about 10, 15 new monitoring elements that can help you see how much, extraction is extracting. Later in the slide deck, probably in the backup slides, I put some helpful SQL that you can use to help with some monitoring, just to see how things are functioning. Yeah, and then PD logs is the easier one. That's what we use in development. PD logs gives you a sort of picture. I'll show you some of what that looks like in a minute or two. Pretty much, there's two things when dealing with extraction. Because underneath the covers, it's kind of like infinite. There's two configuration parameters, max log and num log span. A lot of people have these set for infinite logging environments because they want to make sure that there's no rogue, I call it a rogue transaction that consumes up too much disk space unknowingly, unwittingly, okay? So it is still always interesting or worthwhile looking to keep these parameters set or tuned accordingly, because you don't want, one rogue transaction consuming, file upon file upon file, and you're like hundreds, thousands of files, head extent is thousands of files back because you had something that was unexpected. So extraction will solve this problem because it will avoid the transaction log full, but it will use up more disk space, which may not be what you expected because you weren't aware that this rogue transaction was happening. So you should revisit what your numlog span, number of files a transaction can span. Load and utility type operations aren't impacted by this, so that's fine. But if you have like insert, update, delete, something that's doing something for a long time, sitting around for too long, you may want to revisit these. The key thing is you don't want them to be too small because you'll never give extraction a chance to kick off, okay? So setting them a little bit higher, some of them set them to be log primary, the numlog span, so that will allow us to still extract, but if a transaction happens to span log primary or log primary plus log secondary, then that's sort of the signal to say, hey, this is not normal. Maybe we should be fixing this, okay? So that's something that customers can start to figure out a little bit more. It's tough for us to figure that out because we don't know exactly how people's rules and regulations are for what is considered rogue. But again, that's something that over time we can get feedback on, and potentially we have ways to help out in that to make it less of a manual process. Infinite logging is supported. Pretty much the biggest thing with infinite logging is, like I said before, for finite logging or log secondary not equal to -1, it is still possible to hit transaction log full if your workload doesn't model well, or there's one of those throttling reasons that I said. But in infinite logging, you will always never have transaction log full. So infinite logging avoids the transaction log full problem like it always did before. With ALSM on, you also reap the benefits of not having to go to the archives for rollbacks and crash recovery. So all those negatives of infinite logging can be dissipated because of the fact that we keep what you need local. So that's something to play around with or think about as well. Mirror logging, we came up with support in mod 5. Mirror logging really is just we pretty much use the primary path only for writing extraction log files. So there will be no extraction log files in the mirror path. We only do it in the active path, but we do go to the mirror log path for reading. So writing is always to the primary. Reading can come from the primary or the mirror. So that allows us, some level to work with mirrored logging. That was the main thing, what we tried to achieve. So that's why we call it basic support. But obviously the long-term goal would be, hey, I want to be able to write to both paths because, if any file, any path goes bad, I want to still have extraction. So most of the problems with mirror logging was due to individual files going bad. So if that's your main problem, everything works great with ALSM. If your main problem is the entire path goes bad, like the primary goes bad, then, this will not, the mirror log support will just say, hey, I can't do any extraction. I hit IO errors, and extraction will idle itself. And then eventually, if you don't resolve it, you'll hit transaction log full. Mod 6. So now we move up to mod 6, and we did the backup and HEDR support. Okay. So the biggest things on this is really, I'm just looking at the time, probably got another 8 minutes to go. Martin, hopefully that's okay.
No problem. Keep going.
All right. Cool. So pretty much with backup, the whole thing is we created new extraction log files. Those extraction log files from the starting point of recovery, which is the beginning of a backup image, we need to have coverage for that range of extraction log files, okay? So you have to put those objects into the image. We just weren't able to contain that work in previous versions, but in mod 6, we were able to do that. So extraction log files now go into the backup image, and they will help you get from your recovery starting point all the way to wherever a point in time you want for your roll forward, okay? So extraction log files are considered like database objects that just happen to live in the active log file. They don't have the same rules as active log files like S files and whatnot. So what we do with these is you're not supposed to know about these files. Honestly, I repeat that. We just manage the system. So if there's a problem with an extraction log file at the time to include it into the backup image, then we will go and start retrieving the log file from the archives and put that into the backup image instead. Anything wrong with the extraction log file will not cause the backup to fail. Again, extraction log files are best effort, but we will try to put as many of those, under normal circumstances, all of those that are necessary, into the backup image, and so you'll have a nice contained unit for recoverability, okay? The only key thing is because we added new files to the backup image, any backup images that were created in mod 6 and onwards have a little bit of a restriction when restoring to older 11.5. So like mod 4 onwards, we built sort of knowledge awareness that, hey, these objects exist. So we would just kind of say, okay, this object is here. I can't restore it, but I also won't fail saying that I have something unknown, okay? So if you have to fall back out of mod 6, you can go back to mod 4, and your images that you create in mod 6, you can restore. Otherwise, from mod 6 onwards, you can back up, restore to mod 7, mod 8, interchangeably, back and forth with no problems, okay? Just a little caveat. So here's a quick little diagram of what a backup might look like, okay? So when you issue the backup command, this is your linear diagram of, you know, starting the backup is right here where we have this little squirrely bracket or whatever we call it. And this is what our load trend and min buff was at that moment. As you can see on disk, extraction had started on X0 all the way up to X4. That's where min buff was, okay? So because we don't extract past min buff, everything after 4 is covered by the active files, okay? So we see X0 to 4 and then S5 all the way throughout. Once the backup is kicked off, we establish what X files are needed to be able to recover from this minimum low trend min buff, which is what recovery, when you do a restore, that's what the roll forward, ensuing roll forward will be. So we know exactly what X files will be needed. And so we'll go off and include these 5 X files, 0 through 4, will go into the backup image. And then the remaining range will be covered by S files, okay? So all these files, the backup will proceed for a few hours, probably an hour, 2 hours. You know, all those would be covered by active files. If those active files aren't local, then we will retrieve them and put them into the image. So that's sort of business as usual. And that's how backup works. Really, it's not that difficult a concept. It's just, this is what the picture looked like at the start of backup. This is what we put into the image so that we can do a recovery from that starting point, okay? Restore, again, it's very simple in that if there's extraction log files in the image, you get them. We don't pick and choose. We don't decide. We at the end of the day, extraction log files are interesting. So in active log files, you used to have a log target. The log target would say, hey, I have all these active log files. I want to put them into some separate directory that I'm going to use for an overflow. Okay, that's for the roll forward. That's the traditional model. Okay. In this model, the extraction log files are there to bridge the gap between what was on disk and then got reused, and that's why the X files sit there and they sit in the active path. So what we do is when we do the restore, we validate up front that the active path that restore will use after the restore for the database is of the correct size, can be used, and then if so, we will stick all the extraction log files in the active path, and they will be ready for the ensuing roll forward, okay? The ensuing roll forward will begin. And again, those X files are on disk. We will pick and choose them and use them as we see them. If there's anything wrong or if any of the extraction files aren't there or there's a problem reading them, we will go to the archives and retrieve to bridge the gap. Again, that's the worst case scenario, but I say that only to tell you that your back is covered in the case of any problems with the extraction log files. Okay. HEDR. HEDR is also kind of, pretty straightforward in that, first of all, because of this part that I just mentioned, where if there's a problem with the extraction log file, we have to retrieve from the archives. That's actually very important for HEDR. Okay, it's actually very important for a lot of DR situations as well. The reason being is, if there is a problem, you restore onto a machine 2. Okay, HEDR is a machine 2 kind of concept, right? Host 1, host 2, you're sending log data across. Okay, on host 2, if we're using the extraction log files for any form of recovery, if we have a problem, like I said, we have to use the archives. But if host 2 doesn't have access to the archives, then it's a throw up your hands kind of moment, because how else am I getting to the data? Okay, so that's the worst case scenario, especially for IO error. Like there's going to be, just like active files. If active files are bad, you can try the archives. If they're not in the archives, then you've got to manually supply that file as well. It's kind of the same thing here also. The only difference is for HEDR, we like to keep high availability. That's the whole point of it. It's recommended that you use a shared archive location. Okay, so if you use shared archive location, that means whatever host 1 archives, host 2 has access to, especially if you do takeovers multiple times back and forth, which means if there ever is a problem with extraction, we can always go to the the archives to get the file, and both sides will actually be able to have access. So that is a very big recommendation. That's something that, default on is a problem, because, there are a lot of customers who can't do this for security purposes. So we'll have to figure out how to handle that. Again, at the end of the day, we would have to, ALSM just isn't usable in this situation. So transaction log full can still occur. We just won't extract. Okay, that's something in the future. That's not there today, but that's, shared archive solves all of that. It'll just function as everything that I've said before. Okay. Literally all these other points is the same thing. There's nothing special. HEDR is a database like no other. You have host 1 that looks like runtime. All the same extraction rules apply. Host 2 is just roll forward, technically under the covers, so all the same rules apply, except for one little small caveat. And that's because on the standby, there's an extra concept for log file management called spool limit. Okay, spool limit is for those situations where your standby replay is falling behind, but your primary wants to ship logs over. And if the standby isn't able to receive those log files, there is, async modes that cause pushback on the primary and causes transactions to hang on the primary. That's not ideal. So the user has this capability of specifying a spool limit, and the spool limit will say, okay, on top of the configured amount of files, here's extra space to store these shipped files that will be eventually used for replay. Okay, so we still want to, extraction still wants to be able to interact with that. So there is sort of some smarts built in to do some basic management. Again, we'll figure out over time if we got that algorithm right. It's kind of like machine learning. I throw that in just because they're smarts. We're going to be able to forecast and see what we had in the past. It might not be there today, but it will be the things that we want to work on going forward. So we have sort of these, the values automatic, -1, finite value 0. Based on all of these configurations, those will, ALSM will look at these and then say, what can I cheat with? What can I chew into, that the spool limit doesn't need? Some people have a big spool limit, but never use it. So in that case, we'll say, no problem. We'll try to use as much of that space as we can. But as soon as the spool needs that space, then we'll have to, give up and say, okay, we're stepping back. We used as much as we could, but now spool needs it. That's more important. It's spool's turn to take that space. So this is based on the different configurations. We have different behaviors based on each of these. The slide deck kind of mentions that, but that's the HEDR support. That's really the bulk of it. So the key thing is, though, what we extract on the primary is different than what we extract on the standby. They're actually seen as two different systems, and we react based on the environment that we run on. Okay, and that's really the HEDR piece of it. So current restrictions, these are just a couple of final slides here. Current restrictions, there is no pure scale support, okay? It just does not work right now. There's many more complications because the log management aspect is quite difficult with many members sharing the same file system. So that one is a future statement. We do work for single and multi-partitions. And also, like I mentioned before, we do not plan to support circular or log retain at this time just because of the physical nature. It just doesn't prove enough of a benefit to manage solutions for those. Again, RFEs would be the route if that is different for your case example. Disk space, I kind of touched upon that before. Because of the way we do things, we try not to steal too much of the disk space because it could be a log second dynamic addition of a file would be necessary. And in that, I don't want to fail a log second creation because extraction has chewed up too many of the files. So we will make sure that that space is always reserved. And so that means you always want to have a little bit of extra space on top of your configured that DB2 can play with and use for extraction. Okay, so that's something to play around with. The monitoring can tell you how much of your log space you're using, and that will allow you to maybe reduce your log primary and your log secondary, and that means extraction can chew up more of the physical space that's allotted to that file system. Really the last couple, I know this I'm over. Thanks for hanging in there, I appreciate it. I just wanted to show the monitoring. These are the monitoring elements that were added to mon-get transaction, also to these get unit of work and unit of work details. And this is what it looks like for PD logs. Right here, you can see in the red, extraction status kind of tells you whether it's healthy or not. If there's throttling, meaning the extraction is idle, it'll tell you why that may be. I think in the slide notes that you'll see later and in our documentation, it talks about what all the different things. So these are all the throttling rules that I had mentioned earlier before. It'll tell you why it's idling, and then you can potentially act upon that. I might have some PD slides later for your perusal. That you can go through and sort of see how do I diagnose a buffer pool flush problem, So this is one that we like a lot in development. I know a lot of users may not like this, but we run this with the repeat option, and this will constantly tell us, every 5 seconds, 10 seconds, whatever, what our logging picture looks like and whether there's any problems. The monitoring fields are just as good, up to you what you prefer. And really here, when you turn on the feature, how will you know that it works? Well, when you run the DB2 PD dash logs, extraction status will tell you that it's not on, or it'll tell you that it's active. The diag log will tell you when a database has been enabled for ALSM. It'll also tell you when the database hasn't been enabled for ALSM, and it'll tell you why your log retained, for example, or using circular. Okay. Really, the future, we want to be on by default. That's a conversation that we're having within. This won't happen in a mod pack. I say that, but you never say never. But ideally, the amount of behavioral changes, this is best suited for next release. There hopefully will be a next release in the near future, so we are looking at that. So we are spending some time looking at how we can handle some of those limitations that I talked about before. Pure scale support, that's also something to talk about. We're debating that as we're pushing in more and more pure scale, especially going to the cloud. Pure scale support for ALSM may become more of a factor than it was before. So that's something that we're going to listen to our audience on. And full mirror support, that's also something that is a little bit of work, but we also want to listen to our audience if that's something that users want. At the end of the day, we don't want to spend too many cycles on building things that customers don't want. We want to spend the cycles on what customers do want, which is making what we have today better than it even is, iteratively better. Okay. And the very last thing that I wanted to mention, I talked about autonomic. I talked about today physical log space, log primary, log secondary, log file size. We want to eventually make it solely autonomic, and what we have created, it's already there today, but it's used in very limited situations, mainly for recovery, is something called log disk cap. Okay, it's a configuration parameter. Instead of doing logical inputs like primary, secondary log file size, we want to do physical. We want the user to say, here's our active file space, and you're allowed to chew up 10 terabytes or 5 terabytes of that. Okay, and we will play within those rules. Okay, so everything that we said before, we'll know how many cached files we'll have. We'll know how many active files we'll have. We'll know how to deal with retrieved log files. We'll know how to deal with spooled log files. All these classification of log files is very difficult to manage, and we push a lot of that on the user. To be autonomic, you have to make that easier. So in order to do that, the only solution that we see to do that is specify or ask the user one time, give me physical space. What are my boundaries and what are my limits? And then I can write all sorts of learning algorithms that can stay within those bounds and make sure that the system manages itself as the day-to-day processing goes on, okay? You got an online backup going on. I'm going to keep a couple of extra files on disk so that you don't have to retrieve them. Okay, same goes with read log. Same goes with log spool. Okay, like I said before, you know, you need log spool space. Okay, I'm going to do a little less extraction. I'm going to get rid of, maybe I'm going to pre-allocate files instead of having my whole log primary allocated and half of those files sit empty until we finally write to them. I'm only going to allocate a smaller amount of those files that keep you moving without noticing the blip on an on-demand allocation of a log file. Okay, these are all the log management aspects that DB2 has to look at under the covers. And today, those are all based on 3 configuration parameters, which is primary, secondary, log file size, and very rigid and fixed algorithms and rules. When we go autonomic, it's a lot easier to make these decisions on your behalf using past history, using smarter algorithms. And this is where log disk cap will hopefully go one day. Today, we use it for recovery, only because for recovery, we've gone the model that if you're doing a recovery, we need to reach the end. We don't want recovery to fail because that means it's an outage to your availability. So what we do is we take up the disk space. We run sort of a log disk cap -1, which says we will use up as much disk space as we can to ensure you that your recovery will work. Okay. Eventually, if that becomes problematic for users, there can be configurations updated. For now, there is no way for the user to tune this parameter. It's only, the default is, I think, 0, which means it doesn't work. And internally for recovery, we turn it to -1 also for upgrades because we want your upgrades to work. We just pretty much go into the mode that we say we're going to take up as much disk space as you have in order to finish the one-time operation that you're doing. But as you can see, this configuration parameter has a lot of potential. It has a lot of room for better definition. Don't kid yourself. And that will all come when we start, hopefully one day, investing in that. I don't know when that will be, but iteratively, like I said, we'll get there. That's sort of the theme of this entire presentation. We're coming to the end. Here are the resources. IBM documentation talks about ALSM. It covers about a lot of the things that I talked about. 11.5.6, 11.5.7, we came out with a lot of new features, including some logging enhancements. You might want to look there. For those of you, eventually, I think I'm going to share these slides with Martin. I'm going to jump real quick. You'll see in the backup slides, you know, all the beneficial stuff, some queries, and then that will help you. And then I have all these sections on Mod 6 and Mod 7, all the new features that come out from the availability space, including support for remote storage for log archiving. These are all things that you can look at on your own time, but I thought I wanted to put it here because I like to always share all the new stuff that we do here at the lab because, you know, if you guys don't use it, then what's the point, right? So, yeah, that's about it, Martin. I guess we go back then to, are there any final questions?
Actually, you did a very technical topic and you did a great job. We didn't get any questions from the audience, but with that in mind, let me take control back here for just a minute. Make myself the presenter. And I'll ask our famous last question, which is, did you learn anything today? And we'll see what people say to this. And as expected, we have enough of the audience here to call it a quorum, and 100% of our audience learned something today, as you would expect with a brand new feature that will be useful to them. So people paid attention, learned something, and yes, Marco, the slides will be part of the replay blog. They'll be coming out either later today or over the weekend, depending on how busy I get chasing chihuahuas around the house. But I'll get them done as soon as I can, along with the other things that I have to do for other things. But I'll get them out shortly, and they will be available. So with that, I'll thank you again, Michael, for coming on and being doing such a great job. The audience is appreciative, as always. So once again, look for the replays, and we will speak to you all next week on the DB2 for ZOS show. So
thank you very much.
Thanks again, Michael, and we will we'll see you again soon on the DB2 Next show. Bye-bye.
Bye.